Hello everyone, my name is Annika Smith, and welcome back to the 7th video of the Stat 231 series. So in this video, I'll be covering some content from chapters 1, 3, 4, and 5. A lot of this might be some things you've seen in other videos, so I won't go into the 4 and 5 stuff in too much detail, but I want to cover some of the main stuff you'll see from chapters 1 and 3, but not all of it, so you should also look into some slides and stuff. So, to get right into it, Annika's friend makes the bold claim that at least 60% of people have heard of the rapper NBA Youngboy. And after some discussion, the two narrow down the claim to at least 60% of people ages 19 to 25 in Ontario have heard of NBA Youngboy. Now, I've never heard of this guy, so I set out to prove my friend wrong, as I do, by asking 55 people the following question: Have you heard of the rapper NBA Youngboy? So I'm kind of lazy, kind of shy, and I also have the incentive to be correct. So I only ask people I know at the University of Waterloo. And of that group, I only get around to asking those I ran into over a period of 3 days. And I record yes or no for each response. And I also take some notes on the comments people have about NBA Youngboy, because it was kind of amusing, some of the things people said. But of the 55 respondents, 28 said yes. So, to cover the chapter 1 and 3 content, we want to first talk about what type of study is this. And we have three different types of studies that we look at. So that would be the sample survey, the observational study, and the experimental study. And we see that this one is going to be a sample survey because the population is finite, data is only collected once, and the question asked is specific. And if you're curious about this stuff, I was just looking at TJ's notes on the Stat 231 Discord because I found them a pretty good summary of all of this chapter 1 and 3 content that I kind of needed to brush up on. So, to get right into the next one, what type of problem are we focused on? Well, there's the three types: descriptive, predictive, and causative. And this one is going to be descriptive because it aims to describe an attribute of a variant of the population. So we're just describing, okay, like how many people or what proportion of people know this rapper. So then, what type of variant is Have you heard of NBA Youngboy? This would be categorical because the units fall into non-numeric categories. We're either putting yes or no, and it can also be considered binary because we only have those two options. And the other variant, the comments on NBA Youngboy, are complex because they're very open-ended. People said a wild variety of different things about this rapper, whether they loved him, whether they thought ill of him, or whatnot. So, very open-ended. But what type of attribute are we examining? Well, to define an attribute, we have an attribute is a function of a variate, which is defined for all units of the population. So the attribute we're looking at here is the proportion of people who have heard of NBA Youngboy. And then, what is the target population? That would be the one that we agreed on, which was people ages 19 to 25 in Ontario. The study population is the people I actually set out to survey, who I plan to survey. So that would be people I know at the University of Waterloo. So we have a pretty big jump from the people all ages to 25 in Ontario to the people at the University of Waterloo. So you can probably see there's quite a bit of bias in here. But we'll get into that with our sources of error. And the sample population is the people of the study population who I ended up surveying, and that would be the people I texted or ran into over that period of 3 days. So, we want to look at one potential source of study error, which would be the difference between the target population and the study population and the attributes we measure with that. So, the difference would be that I only interviewed UW students that I know. I don't know NBA Youngboy, so many of my friends also do not know NBA Youngboy. That's just kind of where our music preferences lie. My sister went to Tyler the Creator in Toronto the other day, so I'm sure if you asked a bunch of people there, a lot more of them would know NBA Youngboy. But I was surprised at how many people know this guy, so I kind of live under a rock, but oh well. And then what is one potential source of study error? And that would be that I only interviewed people I texted or ran into over these 3 days. And this would be biased with people I sit near, people I talk to all the time. Again, most of these are my friends. Most of these people have like similar-ish music taste to me. Not the case for everyone, obviously, but I found a lot of them did not know NBA Youngboy. But still over 50% did. So I thought there was going to be like zero, but I just know nothing about rappers. So that concludes my whole kind of overview on some questions for chapter 1 and chapter 3, but definitely more stuff to look into there if you would like to kind of really drill in on that chapter. But for some quick coverage of Chapter 4 and Chapter 5, I have these two questions here. And this first one here is very similar to another video I did, so I just want to kind of go over it pretty quickly. So first, we need to figure out what model we're using. Because we have only our two options, we can think of that as like a success and a failure. We have individuals, we assume that they're independent of each other, and we assume that there's the same proportion of success amongst the entire population. So all of those things should be clicking in your mind as we are looking at a binomial distribution with n is 55 and theta is our unknown true parameter. So what is that? What does our equal-tailed confidence interval look like for that? Well, that would be theta hat plus minus a to this theta hat, 1 minus theta hat, which is our variance of the binomial, over n. So we can plug in all those things. We have that 28 over 55 is this guy is y over n for the binomial from chapter 2, plus minus a over 28 over 55, 1 minus 28 over 55 over 55. So this a here is going to be equal to, because we're computing a quantile here, we want to use q norm, so we're doing the asymptotic one, and because we're interested in the 99% equal-tailed confidence interval, we want to compute 1 plus p over 2 to plug in as our argument here, which we would get is 0.995. And then when we compute this, I can just jump over to RStudio and go up here, and we get that it's 0.258. Or 2.58, my bad. Yes, okay. So, once we throw all this in there, I have it all queued up in R already, so we just run all of these guys here. The lower bound is 0.335, and the upper bound is 0.683. 0.683. So then from there, that's our confidence interval. We're done with that question. But we want to jump into our one-sided hypothesis test, where our theta is 0.6, and our alternative is that theta is less than 0.6, because that's kind of where our data is pushing us towards. We have less than 60% of people say yes. And we're also going to use the exact test statistic, which is based on the binomial distribution. So I'll show you what that looks like. I'm not like super confident with the exact test statistics, so I literally copied this directly from, realizing this should be like that. I copied this directly from Adina's lecture 21, slide 12. I think that's like the last slide in lecture 21. But it basically goes like, we define our y, which is the binomial with the 55 and the theta. We define our H naught, which was 60%, and our HA, which was theta is less than 60%. And then our test statistic is just going to be the difference between the two as an absolute value. So we got that 28 people said yes, and based on our hypothesized value, we interviewed 55 people, and if 60% of them said yes, then we'll have that 33% or 33 people would have said yes if this 60% is actually true. That's our kind of expected value. So we can get the difference between these, which is 5, and that's going to be our little d value that we use. So then to calculate the p-value, we do the p of y minus 33 is less than or equal to -5 under the null hypothesis. That's a very ugly semicolon, but just bear with me. And then we want to move the 33 to the other side, so we get that this is less than 28 under the null hypothesis. And then this one is a little bit weird to compute. We don't normally see this function a lot, but you can do this based on I always forget whether it's PDF or PMF, but the thing of the binomial distribution, or you could just use this R code if you have it available. So we get that it's going to be 0.108. So put that down here, 0.108. And now I can hop over to my cheat sheet, and I see that the p-value is greater than 0.1. So, whoops, I write that there is no evidence against H naught based on the observed data. And then that is my conclusion there. So I wasn't able to prove my friend wrong. Um, Even if I had a lot of evidence against, it would be more in my favor, but I still wouldn't be able to exactly prove anything. But unfortunately, I had a mistaken idea about this whole wrapper thing, so there was no evidence against H naught in light of the observed data. So that's just how it is sometimes. Sometimes we spend a lot of money on a study or a lot of time and it doesn't pan out the way we expected it to, which is all right. And then for a bonus question, I have some stuff down here, and I have all the information available to you with this R code plus your calculator you should use. You should be able to do all these questions just with the information available to you. So pause the video, try it yourself, and then I'll get talking about the question and what we're doing here. So, Annika's friend's favorite food, this is the same friend. His favorite food is garlic bread, but he thinks it's a weird favorite food to have. And I'm like, that's not weird. Like, I feel like garlic bread is pretty tasty and like people can have that as a favorite food. So I set out to prove him wrong again. And I ask everyone, do you think having garlic bread as a favorite food is weird? And I asked this question along with the NBA Youngboy one, because it's just convenient that way. But I'm so amused by what some people are saying about NBA Youngboy that I forget what their response to the second question is. This only happened like maybe once or twice, but it definitely happened. And I put down my best guess, and it's a 50-50 shot, kind of, or maybe it's not. We're here to prove that. So, of the 54 respondents, 11 said yes. And first, comment on a potential source of measurement error. Well, we talked about that a little bit. So, one potential source of measurement error is my faulty memory when it comes to recording the answers. I might have forgotten to write some of the answers and written them incorrectly. So, that's a measurement error there. Other types of measurement error that you might see are people recording the responses in the survey wrong, or if you ask an ambiguous question, people might not answer the way you want them to, or if you have any sort of machine that's measuring something like the temperature of something or like the width of something, it might have a little bit of inaccuracy. So that was a quick summary on measurement error. And then compute the 95% confidence interval using the asymptotic pivotal quantity. So when you do all that using the R code, you should get this value here, 0.096 and 0.311. And then then we have our one-sided hypothesis test, and I have all the steps here for you. So we first define our distribution and our null hypothesis and our alternative. And then we calculate our little d, which is this 0.786. So then luckily our R code, you can see, okay, we got our 786. Well, I think that one's a typo there. Oh well. But then we go along here and our p-value of d 786 is this 216 value here, which we got from the p-norm of this guy, lower tail equals false. And then our conclusion, because that's greater than 0.1, there is no evidence against the null hypothesis based on the observed data. So I hope that kind of gives you a quick overview of all these chapters that we've had before the final. And I look forward to seeing you in the next video.